Alright, so here's a video for worksheet 3. 8.3 is a standard deviation. Most of you, almost every single one of the students in class were very familiar with finding the standard deviation. I just want to go over one more time in case a student was absent or just needs a little bit more review. So, standard deviation, we talked about it. We have to first find the mean. Let me find my notes here, a little paper here so I can write some notes, just so you can have an idea. In order to find the standard deviation, first of all, I am not going to be writing the word standard deviation every single time. We're going to use this symbol right here, which is a sigma. We're going to be using that so we can represent standard deviation. In order to find the standard deviation, we always first find the x bar, which is the mean. Okay? We always find first, we find the mean. Then the second step is to grab every single x value and subtract the mean from it. Every single one of them. That's my second step. And then the third step is to square those values. Whatever that value is, every single one of them, after I subtract the average from it, I will square it. And then, once we're done finding all those values, the fourth step is to the sum. We know that this represents the sum of all. Okay, is the sum of all of these values, x minus x bar squared, and then we're going to divide by n, which is the total number of values. How many, okay? So that is our variance. Okay, that is our variance. So first I need to find the average, then subtract from every x value, then square it. Then I can find the variance by adding all of those squared differences and then dividing by how many are there. Finding the average of the squared differences. And that is the variance. Now for the standard deviation, you'll just have to take the square root of the variance. Okay? And that is pretty much the steps to find your standard deviation. First, you need to find the squared difference between the x value and the mean, sum it all up and divide it by how many are there, and that is the variance. Then you find the standard deviation. So be familiar with the symbols. I'm going to use them all the time. Okay? So it is nice to have everything written in a nice little table, and that's why here in this worksheet 3, we put in a little table. Hopefully we're trying to help you kind of like get used to the process of finding the variance first, then the standard deviation. Okay? So they already started the box for us, so which is nice. They have all the x values here, and these are Elvira's exam scores. Okay? And they said that the average of her score is 86. So first you have to find the average. They already found it for us. So now all you have to do is subtract every single one of the x values minus the average. So 85 minus 86, 85 minus 86 is -1. And you're going to do that for every single one of them. 87 minus 86 is 1. 90 minus 86 is 4. 84 minus 86, now be careful, those were higher values. This is a lower value, so 84 minus 86 is -2. 87 minus 86 is a 1. 85 minus 86 is a -1. 84 minus 86 is a -2. 86 minus 86 is 0. 87 minus 86 is 1. And 85 minus 86 is -1. So we found the difference between the x value and the mean. Now we need to square these differences. So -1 squared is 1. 1 squared is also 1. 4 squared is 16. -2 squared is 4. 1 squared is 1. 1 again. -2 squared is 4. 0 squared is 0. 1 squared is 1. And 1 squared is 1. Now, for the variance, we must sum up all. This is the sum of all. Okay, you need to sum up all of the x's minus x bar squared, and then divide it by how many are there. Okay, that is the little formula for variance. So let me sum up all of these numbers and divide by how many are there. When I sum them all up, I get that there are 30 of, okay, 30. So if you add them all up, you get 30. and I divide by how many numbers are there. There are 10 values. Divide by 10, and you get that the variance is 3. So the variance is 3. Okay, 30 divided by 10 is 3. Now, the standard deviation is the square root of the variance, which is 3. And the square root of 3 is 1.73. Okay? So that is how you find the standard deviation. You have to first find the variance and then find the standard deviation. Okay? I am not going to waste too much time with this because all of you were successful in class finding the standard deviation. And here, they didn't do it for us. You have to do it yourself. You're going to put Bob's scores here, okay? Starting with 53. Then, I mean, it's nice to put it in order, but you don't have to. Just put in the exact same weight as there. 53, then 97, then 75, and then 80, and so forth. I'll let you finish. Find the average. First, find Bob's mean. You need to find the average of Bob's test. I'm pretty sure Bob's average is 76, so I'm helping you out here. Okay, if you add them all up, Bob's test, you get 76. That means I'm going to be subtracting 53 minus 76. Okay, so 53 minus 76 equals what? 53 minus 76 is negative 23. And then you're going to square that. Negative 23 squared is 529. So that is exactly what you're going to be doing for all of them. And you're going to find the variance and you're going to find the standard deviation. Be careful because the variance causes a little bit of confusion, okay? Is the sum of all of these numbers right here divided by how many numbers did you add up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing with Bob. He also has 10 test scores, okay? So you're going to add up all these numbers divided by 10. That will be your variance. All right, so that is pretty simple. We did it all in class. Go ahead and finish it that for you to compare which one, Bob or Elvira. This is Bob, this is Elvira. Which one has the highest standard deviation? We discussed in class, the more the data is spread out, the higher the standard deviation. The closer the data is to each other, the numbers are, the smaller the standard deviation. So if you look back up here, okay, the very beginning, before you even knew about Elvira's standard deviation, look at how her test scores are closer together. She has lots of 80s, and then she has 190. So they are more close together. So Elvira's, which student do you think has the lower standard deviation? I'm going to go with Elvira. Okay, I haven't even solved for Bob yet, but I feel like Elvira's test scores are closer. Now look at Bob's. They are 70s, 40s, 50s, 90s, even 60s. He's all over the place. So Bob's scores are more spread out. So I have a feeling that when you are done finding Bob's standard deviation, will be larger than Elvira's. Okay, Elvira's was 1.73. That's the average of the distance of the scores. It looks like they're closer together. Okay, so I'll let you analyze that, remembering that idea of the closer the values are together, the smaller the standard deviation will be. And to prove that to you, let's talk about letter F over here. Okay, I just want you to have an idea. What is the standard deviation of a class if everyone in the class got an 85%? Take a look at it. Bobby got 85, Elvira got 85, Johnny got 85, Jenny got 85, and everybody got 85, 85, 85, blah, 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 85. If I was to add up all these numbers and divide it by how many are there, my average would be an 85. And then I'm going to subtract my average from every single one of these values. 85 minus 85 is 0, and 0, and 85 minus 85 is 0. So I'm going to get 0 as my x minus x bar. They're all going to be 0. And then I'm going to square zeros, and I'm going to get zeros. And I'm going to add up all the zeros, I'm going to get zeros. And you're going to see that the standard deviation is going to be, the variance is going to be 0, and the square root of the variance, which is 0, is going to be 0. So the answer here is, what is the standard deviation? The standard deviation will definitely be 0, okay? because I know that the average is the same thing as the values of x's. Okay? So that shows that the distance, because the standard deviation is 0, there is no spread of the data at all. The data is not spread out, is exactly the same number. So I hope that helps you understand the standard deviation. What is the standard deviation representing is how spread out the data is. Okay, the data values are. Okay? So 13 is another standard deviation practice. It helps you a lot if you set up your little table. Even if it's just a little tiny little table, you have 13, 15, 17, 18, 12, 21, and 10. Ooh, I barely fit there, okay? Let's find the average of those numbers. To find the average, here's my little x bar. I need it because I'm going to subtract every single x minus the x bar, okay? So let's find the average of these numbers. Simply, all I'm doing in my calculator is adding 13 plus 15 plus 17 plus 18 plus 12 plus 21 plus 10, and that equals 106. So that's 100, the sum, okay, the sum of all the x's is 106. And I'm going to divide by how many are there. I'm going to divide that by 1, 2, 3, 4, 5, 6, 7. I'm going to divide by 7. So I use this little sigma, the sum of all the x's, 106 divided by 7 gives us 15.14. I'm going to take the liberty to round it to just 15. Because now I'm going to subtract 15 from all of these numbers. My x bar is 15. So I'm going to subtract my average x bar from every single one of them. 13 minus 15, that is a negative 2. 15 minus 15, that is a 0. 17 minus 15 is a 2. 18 minus 15 is a 3. 12 minus 15 is negative 3. 21 minus 15 is a 6. And 10 minus 15 is a negative 5. Barely able to fit in there. Now what I'm going to do is I'm going to square every single one of these values I found. Okay? So negative 2 squared is a 4. 0 squared is a 0. 2 squared is a 4. 3 squared is a 9. 3 squared again is a 9. 6 squared is a 36. And negative 5 squared is a 25. That was better. I was able to fit it nicely. Now all I have to do is first find the variance. The variance has this little symbol that says add up, sum up all of the x's minus the x bar squared and divide it by how many are there. So I'm supposed to sum all these numbers up and divide it by how many are there. There are 7 values, okay? It's the same as when we counted here. 1, 2, 3, 4, 5, 6, 7. It didn't change how many values are there. Now let's add them all up. That's 4 plus 0 is 4, plus 4 is 8, plus 9 is 17. Let's keep going. So we have 17 plus 9 plus 36 plus 25. I got 87. Let me check again my arithmetic because sometimes I do it so fast. That's 8 plus 9 again plus 36 plus 25. 87. Good. And 87 divided by 7 gives us 12.43. Let's round it to 2 decimal places. 12.43. That's my variance. So they said find the mean right here, find the variance right here, and now find the standard deviation. The standard deviation is just the square root of the variance, which is 12.43. Okay? And if I take the square root of that, I get 3.53. 3.53. And there is my standard deviation. Mean, variance, and standard deviation. Okay? So hopefully you can do that for the next few numbers, and then you can compare which one of these values, A, B, or C, which one are more spread out. The more spread out, the bigger your standard deviation will be. Okay? Good luck. We did discuss this thing right here. What happened? We did a bunch of investigation in class. Was tedious. We kept on adding 2, adding 3, and multiplying by 2, multiplying by 3. We did this. What happens? How does the mean and the standard deviation changes when I multiply each item by a constant or when I add each item by a constant? Okay, I want you to figure that out. If you missed that investigation in class, I want you to play with it and figure it out. Okay? Good luck.